Hello Algebra 2 class, this is once again Mr. AC at your service. I will be going over a brief summary of what we learned in class on Thursday. Now I want to mention that we covered a lot of things in class, so it's going to be super important that if some of the stuff that we go over right now is not very clear, that you come in and see me, because I'm going to try to condense an hour and 45 minutes of class time, or whatever time it is, 105 minutes, all into a quick short YouTube video. So there's actually a few things that we learned, but there was a lot of work that went into it. So the first thing that we kind of talked about was projectile motion. Now, it's important that we all understand what projectile motion is. One of the definitions that was given in class, I believe Tyson and a few others, I forget who said this in third period, but it was that projectile motion is anything that is like an object that's in the air. So maybe an example of projectile motion might be something that a lot of you are familiar with right now because the Seahawks are in the Super Bowl. Is an example is a football. So I'm just writing down a football being thrown. It's just anything that travels in the air. A basketball, a football, fireworks is another great projectile motion. It's just anything that you toss and goes down. Now, another thing that we talked about was, why is it that when we have an object and we let it go, it goes down instead of going up? Well, one of the things that we talked about was gravity. Gravity always pulls objects down. So that was kind of another key idea that we're going to go over. So one thing that might help out to at least get us to understand some of the concepts is I posted a video. It's on the channel. It's called Projectile Motion Video. And you're going to see there that I was kicking a soccer ball from the rooftop of my house. So maybe I'll draw a quick picture here. This is my house. And here I am. Now, keep in mind that I'm going to be erasing things because I don't have a lot of space, but I need you to be taking notes as well, alright? Or just watch the video. But you might need to take notes because I might erase some parts. So I had a soccer ball and I kicked it. And it made this kind of motion. Okay? So basically, just as you would expect, if I kicked the soccer ball from the rooftop of my house, it went up and then it went back down. Now, I want you to keep in mind that the height from the ground to where I kicked the ball was about 4.054 meters high. So when I kicked that ball, we were 4.054 meters high. Okay. Now, one of the things that we did is, well, we talked about that projectile motion, anything that resembles this shape right here. If you look, it kind of looks like a upside down U, right? Anything that we do. So for example, we have a firework that we shoot, it's going to look something like that. Remember, this right here is when we talked about in class, said that this was something that looks like a quadratic equation. It looks like an upside down parabola. So we were able to discuss in class that projectile motion will always be degree 2. Always going to be degree 2. Now if we look back on our notes on Tuesday, since we know that it's going to be degree 2, we know that the polynomial is quadratic, so we know that our equation is going to look like ax squared plus bx to the 1 plus cx to the 0. Now remember, what the definition of degree is, that is our highest exponent, which is why we don't know what a is. Remember, we're going to try to find that out, so we start with the first letter of the alphabet, and degree is the highest exponent, so that's where we have the 2. So we have ax squared plus bx. We just put the b because we're just going down the letters of the alphabet. We'll figure out what those letters represent later, and then we just subtract 1 from the exponents every time from the definition of a polynomial. So it's going to be 2 minus 1 is 1, and then 1 minus 1 is 0. Okay, now that we have this information down, in the video where I talked about earlier, I gave us three points when I kicked the ball from the rooftop of my house. I gave a point about here, I gave a point about here, and I gave a point about here. Okay, so I'm going to erase some things down real quick. Okay. So we know that our equation was ax squared plus bx to the 1 plus cx to the 0, okay, equals f of x. Before I had it as y equals, but here in this case I'm just going to have it as f of x equals f of x. It's the same thing, it's just our output. Now I picked 3 points, and I'm going to do it while I set up the matrix. So the idea was that we set up this matrix. I gave you 3 points, and remember, we're trying to find out what A is, we're trying to find out what B is, and we're going to try to find out what C is. So if we have 3 variables that we are trying to find, that means we have to pick 3 points. But I actually gave you those 3 points, and those 3 points were this, as follows. Okay, I gave you 0.4, 6.26. So I'll write it up here. 0.4, 6.26, 1.1, oops, 1.1, which was 6.35, and then I gave 1.6, which was 3.47. Okay, this was the time, and this was the meters. So at 0.4 seconds, when I kicked the height of the ball was at 6.26 meters. And then at 1.1 second, the ball was at 6.35 meters. And then at 1.6 seconds, the ball was at 3.47 meters. So as time elapses, we see that our ball should slowly start to get closer to 0 because it's going to hit the ground. That's why you see these numbers going down. Now, it might be very important for you to go ahead and look at the video I posted on this actual demonstration where I actually kicked it off the rooftop and actually put the points down, if it helps you understand where that's coming from. So we put our points here. I put the first point here, which is the one that I put up there with the 0.4. This one is going to be 1.1, and then it's going to be 6.35, and then we have 1.6, and this is going to be 3.47. Okay. If you watch the other videos on finite differences and setting up, if you look at the video setting up the matrix, you'll see exactly what I did step by step. But basically, you're going to have 0.4 squared, 0.41, and then 6.26. Basically, for our x value right here, this is my x, my time. This is my y, my output. I'm going to take my x, I'm going to plug it in for x squared. So instead of x squared, we have 0.4 that's going to be plugged in here into our input. So we have 0.4 squared here. So it's going to be 0.4 raised to the 1. And then we're going to get 0.4 raised to the 0, which is just 1. Here's my output, and then 6.26 is my output. Alright, so if this seems rather confusing, I recommend you watching the video that I posted online about setting up our matrix. I think that's going to be super helpful. At this point, I just want to storm through this part just so I can help you out with the stuff that we got figured out. Okay, so that's how you set up the matrix. So you kind of get to see another way of setting up the matrix. Once you enter that into your calculator and enter this matrices into your calculator, the final thing that you should keep in mind is that rows are a horizontal line. So here we have 1, 2, 3 rows. We have 3 rows, and then here we have 1, 2, 3, 4. So we have 4 columns. So I'm going to have to go ahead and if you need help setting that up, you're going to have to come see me before, after school, during lunch, or any time, because my calculator does not have the actual setup to show you how to enter this, but I do have what we got. So essentially, this is the equation that we got. Okay. We ended up getting that our A value was negative 4.907. Our B value was 7.47, and our C value was 4.049. Okay, so now all we do is we're going to take our A value, We know our A value is right here. We know my A value is negative 4.907, so I'm going to plug that back in here. So my final equation is just going to be, we're just going to get the final equation to be 4.0907 x squared plus 7.47 x to the 1 plus 4.049 x to the 0. But remember, anything raised to the 0 power is always just, that's right, you got it, it's just 1. So we can actually just leave this out because I'm running out of space, and equals f of x. So this was the equation that modeled my situation where I kicked the ball from the rooftop. Again, you can check that on the channel, I got it. So essentially this is the big ideas that we deciphered in class, and it's not as exciting because all the work was done by all the students, and so everyone contributed to this, but we kind of just had to give it to you, so hopefully this helps out. The reason why this is negative 4.907 is because gravity pulls us down, and this is what our A value kind of represented. This was our acceleration due to gravity. So the reason again why it's negative, the reason why objects always fall down is because gravity pushes it down. And this is basically gravity cut in half, which is negative 4.9. Approximately negative 4.9. So this A value, anytime you're dealing with projectile motion, is our acceleration due to gravity. Now if you look here, remember earlier in the video I told us that the height of my house where I kicked the ball from was 4.054. Now if we look at our equation, our C value is 4.049. It's approximately, it's really close to the height of when I kicked the ball. So we used multiple examples to just double check, and we ended up realizing that the C value was the height of the ball when it was kicked. Okay. So our A value represented acceleration due to gravity. It's what pulls object down. It turned out our C value in projectile motion, from many examples, I'm just doing one, it turned out that our height of when the ball was kicked was always generally our C value right there. And then finally, this value, our B value, turned out to be our speed. Okay, speed is distance divided by time. Okay, so if you're driving on the freeway and you're going 60 miles per hour, right? That's your distance divided by time. Another word for speed, actually they're a slightly different. Speed and this word I'm going to say are a little bit different, but for the purposes of this video, I'm not going to really go over that. What's another word that we usually use sometimes with speed? Well, that's velocity. So our B value is also velocity. Okay, now that we know that information, now we can finally go ahead and make our key observations about projectile motion. And this was kind of like the big important stuff that we kind of covered in class. And again, this is kind of a short video clip and not as fruitful, but you know, this is the best that I'm trying to do. So hopefully this is making sense. If not, come to class and ask me for help. So basically we know that our A value was acceleration due to gravity. It's actually gravity is actually negative 9.8 meters per second squared. And if you divide negative 9.8 in half, so if you do negative 9.8 divided by 2, you'll see that we get negative 4.9. So when we do projectile motion from now on, our equation is going to be 1/2 gravity, 1 half times gravity. Remember, gravity is negative 9.8. Well, if you divide that by a half, if we multiply that by 1/2, we get negative 4.9. Okay, we get x squared plus, remember we said that our B value was velocity, so we're going to label this as velocity, okay, times x. So this reads V naught, which is just velocity. So here we have gravity 1/2 gravity x squared plus velocity times x plus, and we said that our c value when we did all these problems with projectile motion, well, that was the height of when the ball was kicked. So we're going to get h equals f of x. So this was the big idea, was setting up that equation right there. Now, if this 1/2 g is kind of confusing us, let me go ahead and just run through it real quick. Okay, we have 1/2. Okay, I told you gravity, acceleration due to gravity is always, it's the constant rate. It's what pulls objects down. It's actually negative 9.8 meters per second squared. I'm going to leave the units out for now, but negative 9.8 plus our velocity plus our height equals f of x. Okay, well, taking our calculator, and if we do 1 divided by 2, I'm going to show it to you real quick. So if you look here, if you do it yourself on your calculator, I know it's not necessarily zoomed in. Actually, you're not even able to see that. You're going to realize that if you type that in, if you type this into your calculator, we're just cutting it in half. We get negative 4.9 x squared. Oops. I hope you noticed my typo. I forgot to put my x squared right here. There we go. So now, I really apologize about that, but I'm not going to redo the whole video. Good thing I caught that. So basically, negative 1/2 g. G is negative 9.8, so 1/2 times negative 9.8 x squared is going to be negative 4.9 x squared plus velocity initial x plus h equals f of x. Perfect. So, a lot of cases we're going to have our a value, it's always going to be negative 4.9 if we're in meters, if our distance is meters and we're in seconds. Because acceleration due to gravity always pulls it down, and in projectile motion it's always 1/2 of gravity, which is negative 4.9, which is why in our problem we got really close to negative 4.9. Wasn't exact, it was negative 4.907 because of human error. So this was kind of the big ideas that we went over. We're going to continue to pick up on this in class on Monday. Thank you.